This question is from topic relative velocity. In this question, I is a unit vector due east, which means its magnitude is 1 and its direction is from left to right. And j is another unit vector due north, which means its magnitude is also 1 but its direction is upwards. In this question it says that exactly at 1200 hours a ship leaves a port P and travels with a speed of 26 km per hour, which is the magnitude of the velocity in the direction of 5i plus 12j vector. For the first part of this question, we have to show that the velocity of the ship is 10i plus 24j km per hour. Now, before solving the actual problem, let's discuss some relationship among the vector, unit vector and its magnitude. So, what is unit vector? Unit vector can be defined as a vector divided by the magnitude of that vector. So let's write the magnitude. But how can we get the magnitude of any vector? Okay, let's say that we have a vector as ai plus bj. Then the magnitude of that vector would be, we can keep it inside the modulus sign, it will be a square root of a squared plus b squared. Now let's get back to the actual problem and let's start solving it. At first we need the unit vector in the direction of 5i plus 12j, but in order to get the unit vector we need the magnitude. So let's try to find the magnitude of 5i plus 12j. So it would be equal to square root of 5 squared plus 12 squared, which is equal to 13. So now the unit vector in the direction of 5i plus 12j would be, so let's write unit vector in the direction of 5i plus 12j is equal to 1 over 13 times 5i plus 12j. So we got the unit vector. Now we need to multiply the magnitude, which is here 26 km per hour. So let's say that the velocity of the ship is vs, so it would be equal to 26 times the unit vector, that is 1 over 13 times 5i plus 12j. So let's simplify it. Vs is equal to 26 divided by 13 is 2, so 2 times 5 is 10i and then 2 times 12 is 24j. So we have shown that the velocity of the ship in the direction of 5i plus 12j is 10i plus 24j. So we have done the first part of this question. Now let's move on to the next part of this question. Let me scroll down the page a bit. I think a bit more would be perfect. Yes, now it's perfect. Okay, here we have to find the position vector of the ship relative to P at exactly 1600 hours. But how can we get the position vector? Let's write the relationship between position vector, velocity and time. Position vector is equal to a velocity vector, velocity times the time duration. We're going to use this relationship, but at first we need to find the time duration. Here the time duration would be equal to 1600 hours minus 1200 hours, which is exactly 4 hours. So we need to multiply this with the velocity vector of the ship. So position vector of the shape. So position vector of the shape is equal to 10I plus 24j. So let's write 24j times 4. So 10 times 4 is 40. So let's write 40I, and 24 times 4 is 96. So let's write 96j. So this is the position vector of the shape relative to P at exactly 1600 hours. So our second part of this question has been done. Now let's move on to the third part of this question. Let me adjust the page a bit. Okay, now here in this part of this question, we have to find the position vector of the shape relative to P t hours after 1600 hours. Okay, that means we have to find the new position vector of the shape relative to P exactly t hours after 1600 hours. But what is the relationship between new position vector and old position vector and velocity and time? Let's see. Let's write the relationship here. So new position vector is equal to old position vector plus velocity times time. So for this question, what is the time duration after 1600 hours? It is, the time duration is t hours after 1600 hours. Therefore, the new position vector of the shape relative to P. So new position vector of the shape relative to P would be equal to 40I plus 96j, which is our old position vector of the shape, plus velocity, that is 10I plus 24j and times the t, which is our time duration here. So let me write the I components together. So it would be 40 plus 10t I and plus, let me write the j components together, 96 plus 24tj. So this is the new position vector of the shape relative to P t hours after 1600 hours. Now let's move on to the rest of to solve the rest of the math. For the rest of the math, they have introduced a new character in this problem, that is a speedboat. It says that exactly at 1600 hours, the speedboat leaves a lighthouse which has a position vector of 120I plus 81j kilometer relative to P, and at some point the ship will the boat will intercept the ship, and the velocity of this boat is minus 22I plus 30j kilometer per hour. We have to find the position vector relative to P of the speedboat t hours after 1600 hours. So it's kind of like the previous one. We have to find new position vector of the boat. So let's write the position vector of the boat, which is actually the new position vector. So it would be let's write the old position vector, that is 120I plus 81j. So it is our old position vector. It will be added with the velocity vector of the boat, that is minus 22I plus 30j, and here the time duration is again t hours. Now let's write the I component together. So we can write 120 minus 22t I and then plus 81 plus 30 t j. So this is the new position vector of the boat relative to P t hours after 1600 hours. Now let's move on to the fifth and final part of this question. Here we have to find the time at which the speedboat will intercept the ship and the position vector relative to P of the point of interception. Okay, so let's say that at t hours after 1600 hours they will intercept. So let's write the position vector of that time. So at the point of interception, let's write their position vectors. So position vector of the ship is equal to 40 plus 10ti plus 96 plus 24tj. Okay, now let's write the position vector of the boat. So position vector of the speedboat is equal to 120 minus 22ti plus 81 plus 30tj. If they intercept at any point at that point of interception, their position vector must be same. So for the condition to intercept, the position vector must be same. Therefore we can write 4 plus 10t is equal to 120 minus 22t. Above I didn't write 22t, so let me correct that thing up first. It should be 120 minus 22t. So I have corrected. Now let's come back to the equation that we were solving. So if we rearrange this equation, we can write 32t as 10 plus 22 is 32, and then on the right hand side we can write 120 minus 40. Now t will be equal to 80 divided by 32, which is 2.5 hours. So after 2.5 hours, after 1600 hours, they will intercept. So let's find the time. So time is 1600 hours plus 2.5 hours. 2.5 hours, which is equals to 1830 hours. Now we need to find the position vector of the point of interception. So we are going to use t is equals to 2.5. So position vector will be equals to 40 plus 10 times 2.5 I plus 96 plus 24 times 2.5 j. So in the next line we can write 40 plus 10 times 2.5 is 25. So 40 plus 25 I and plus 96 plus 24 times 2.5 is 60. So let's write 60 here, 60 j. So it would be 96 plus 60 j. Okay, for in the final line we can write 40 plus 25 is 65 I and 96 plus 60 is 156. So it would be 156 j, 156 j. So the position vector of the point of interception is 65 I plus 156 j. So we have completed this question. Now let's move on to the next question.